Have you ever wondered why humanity's relationship with death has always been so mysterious and complex?
The fear of death is natural, and I completely understand. I'm not saying it's an irrational emotion.
However, the topic I want to delve into with you today has a slightly different angle.
So what I want to explore with you is, what will physics, not philosophy or religion, reveal about the true meaning of death?
And let me warn you, the answer we're about to uncover will far exceed your wildest imagination in terms of strangeness.
So, let's start with something that seems very simple.
What, in your opinion, is death, truly?
I'm asking very seriously. You'd probably answer immediately. It's the moment a person ceases to exist, right?
The heart stops beating, the brain ceases to function, and that person seemingly vanishes, no longer present in this world. Indeed, that's a very natural and understandable concept. And for millennia, this was the only way humanity explained everything.
The past is gone, the present is here, and the future is yet to come.
That's an obvious truth, a belief that everyone implicitly accepted. Until a figure emerged, Albert Einstein, who had a peculiar habit of challenging and breaking all conventional wisdom. So, let's go back to the beginning. In 1905, at just 26 years old and working at a patent office in Bern, a detail that is extraordinary in itself, Einstein published a paper that permanently changed our understanding of the universe. That work is known as the theory of special relativity. And what surprised many was that its core idea was astonishingly simple. So, what is that idea? An astonishing fact. The speed of light is always the same for everyone. It sounds simple, but this is the starting point for all discoveries. Does this sound too ordinary to you? Imagine, light travels at an incredible speed, up to about 300,000 kilometers per second. The strange thing is, whether you're moving towards or away from a light source, its speed remains constant. Whether you're moving or standing still, light always passes you at the same constant velocity. It doesn't add to your speed, unlike a baseball thrown from a moving train. So what makes light so special? From just this seemingly simple fact, Einstein deduced truly astonishing things that changed the way we perceive the world. These discoveries fundamentally challenge what we once believed to be reality. Would you believe it? The first thing he discovered was that time is not as universal as we once thought. When I mention this, many people often mistakenly think I'm talking about metaphors or poetry, but that's not the case. In fact, I'm talking about a scientific truth that can be measured and verified. The astonishing thing is that time passes at different rates depending on how you are moving. In other words, the faster you move, the slower time seems to pass for you, compared to someone standing still. To make it easier to visualize, let's imagine this with me. Imagine an extremely simple clock, a light clock. In it, a pulse of light continuously bounces up and down between two mirrors. And each time the light hits the bottom mirror, the clock ticks once. Can you imagine a perfect, flawless clock operating precisely down to the nanosecond? What makes it so perfect? Simply put, it adheres absolutely to the laws of physics. So what would happen if we placed this perfect clock inside a spaceship hurtling through space at incredible speed? From the perspective of an outside observer, what do you think would change? Surprisingly, for an outside observer, the light beam inside the clock no longer just travels up and down. Why is that? Because the ship is still moving forward, causing the light beam to travel in a diagonal zigzag path. Interestingly, even though the light travels a longer distance, its speed remains unchanged. And as a result, each cycle of light travel, each tick of the clock, takes longer. Do you know what this strange phenomenon is called? It's time dilation. It's important to emphasize that this is not merely an optical illusion. No, this isn't a matter of subjective perception or how we view things. The truth is, that clock is actually running slower. Do you think this only applies to ordinary mechanical clocks? Not at all. It also includes super accurate atomic clocks, or even chemical processes occurring in nature. And most surprisingly, the biological aging process of our own body. This means that if you move fast enough, you will age significantly slower than someone who remains stationary. Do you think this is a science fiction story? Not at all. We have actually measured this phenomenon. To verify this, scientists used atomic clocks, which are the most precise time-measuring devices ever created by humans. And what happened when they placed one on an airplane and flew it around the Earth? Did you know that upon its return, time had actually passed a little slower for it? Slower than stationary clocks on the ground. Only by a few nanoseconds, an incredibly tiny amount of time, because that plane Wasn't moving at a speed anywhere near the speed of light, was it? Nevertheless, this phenomenon is entirely real, precisely measurable, and repeatable in experiments. Have you ever wondered how the GPS system we use daily on our phones works? If engineers didn't incorporate time dilation into their calculations, including effects from special relativity, arising from the satellite's velocity, and general relativity caused by gravity, our GPS system would accumulate errors of several kilometers every day. So the fact that your phone can accurately guide you to specific streets rather than just generally to the entire city is a vivid daily testament to Einstein's theory of relativity. So time is not universal, and that alone should give us pause for thought, shouldn't it? However, that's not yet where things get truly mind-blowing from a philosophical perspective. To truly understand, we need to delve into an even more complex aspect. Special relativity doesn't just tell us that time can speed up or slow down, but it also reveals a much more profound truth. Can you believe that the past, present, and future are not absolute, immutable concepts? What you consider the present might not be the present for someone else moving at a different velocity than you. Let me explain this seemingly incredible concept further. Can you imagine? Right now you are here, but millions of light years away, something is happening. Just think, what if at that very place they just turned on a light? So what exactly is happening right now for you from that location? Instinctively, we often believe there must be a clear answer, right? Simply put, that light is either on or off at this very moment. We often assume there's a universal present that's synchronized across the entire cosmos. But what if the theory of relativity asserts the opposite? In reality, a universal present that applies everywhere simply doesn't exist. The concept of simultaneity, it turns out, is relative. Imagine, if someone were moving at an extremely high velocity past you, their present in that distant galaxy would be entirely different from the present you are experiencing. The astonishing thing is, both of these perspectives are correct. There is no preferred or privileged frame of reference. In other words, there is no absolute single perspective of this universe. And this is what we call the relativity of simultaneity. But this becomes incredibly fascinating when we connect it to our initial question, the question of death. Why is that? Because if the present isn't the same for every observer, and if the laws of physics don't favor one present over another, then what truly defines the boundary between past, present, and future? Are they truly as distinctly separate as we usually imagine? And this is where we explore a profoundly deep concept that physicists call the block universe. Indeed, this might be one of the most groundbreaking and perspective-altering ideas that modern physics has ever proposed. Have you ever thought about space? Right now, billions of galaxies still exist somewhere in the vast universe. Even though you can't see them due to the immense distance, does that make them disappear? No, they still exist. Should we deny their existence simply because they're in a different location in space? Their existence is entirely independent of whether you can perceive or be aware of them. So what if time operated in a similar way? Imagine this. What if every moment, past, present, future, truly exists, just like distinct locations in space? It's not that the past was and the future will be, but that the past exists, the future exists, and the present too, all existing but at different coordinates. This is the concept of the block universe, an idea formed within what we call spacetime. So, is the universe just a temporary stage where all events unfold and then vanish into oblivion? No, the universe is actually a solid, four-dimensional structure, consisting of 3 spatial dimensions and 1 temporal dimension, where all events are permanently etched and unchangeable. Think about it. From the moment you were born, the instant you learned to read, to this very moment as you listen to me, or Einstein's passing in 1955, and even the formation of the sun 5 billion years ago. All these things exist within this grand structure, like points marked on a giant map. And who proposed this idea? It was the physicist Hermann Minkowski, who, ironically, was once Einstein's own professor. Can you believe it? Someone once said Einstein was quite lazy when he was a student. So what incredible declaration did Minkowski make in 1908? He declared that from that point forward, space and time, when considered separately, would fade away, becoming mere shadows. Only a special combination of the two could preserve an independent reality. And that is precisely the concept of space-time. Imagine it as the fundamental fabric upon which the entire universe is constructed. The remarkable thing is that this fabric remains unchanged. It exists perpetually. So let's go back to the question of death. What if the block universe theory is accurate? And I must be honest with you. The truth is, there's no definitive proof for this yet. This is merely one interpretation of the theory of relativity. However, this is an extremely serious interpretation, supported by many top physicists, as well as distinguished philosophers. Nevertheless, the debate surrounding it is still open. So if the block universe theory is correct, what exactly is death? Death. Is it the end? Or more simply, is it just an event, a specific marker in the vast tapestry of space-time? However, surprisingly, it's not a complete disappearance as we often think. Instead, imagine it as a boundary, a dividing threshold. Before that boundary, people exist at certain coordinates. After that boundary, their presence at those coordinates is no more. However, the miraculous thing is that the coordinates before that event do not disappear. They remain eternally present, preserved within the fabric of space-time. So if your grandfather has passed away, has he ceased to exist entirely, erased from this universe? No, he simply exists at a different location in space-time at different temporal coordinates than you. Similar to how he was previously in a different city, just different spatial coordinates. I know what you're thinking. You're probably telling yourself, Feynman, that sounds nice, but what does it really change in the end? If I can't reach those coordinates, can't interact with them, then what difference does this make? And I completely understand that's a perfectly valid objection. I grasp your thoughts. But wait, I want to take you a bit further, because the idea of the block universe holds a much more thought-provoking implication. If every moment exists eternally within the fabric of space-time, then your life, your entire journey, from your first breath to your last, also exists eternally. It doesn't vanish. It isn't erased. It's there, etched, eternal, forever. This is an idea that I personally hold very dear, though not entirely for scientific reasons. But I still want to let you in on a secret. It was Einstein. When his close friend Michel Besso passed away in 1955, just weeks before Einstein himself, he wrote a meaningful sentence to the Besso family. "Now he has departed from this strange world, a little ahead of me." For us, who believe in physics, that holds no special significance. Because the distinction between past, present, and future is merely an illusion, however stubbornly persistent it may be. These are Einstein's own words, not a romantic poem, but the words of a great physicist who always took his theories seriously. But wait, I want you to listen very carefully because this is extremely important. However, the idea of the block universe is not without controversy. Some philosophers and physicists argue that this picture can be misleading. They argue, look, relativity has taught us that simultaneity is merely relative. So does this mean the future is predetermined? Not exactly. It merely reveals that the boundary between past, present, and future is actually very blurry, depending on your perspective, rather than everything already existing simultaneously. Have you heard of the growing block universe? This is an interesting intermediate idea. The past and present are fixed, but the future is still an unknown. Imagine the universe growing, expanding. Each time a new moment officially becomes the present. Sounds more reasonable, doesn't it? This is a significantly less extreme view compared to the full block universe model. But wait, it doesn't stop there. Quantum mechanics introduces thorny problems, and here we're entering much choppier waters, as it seems to imply that some events don't have a definite value until we perform a measurement. Reality at that level? At the quantum level, it is fundamentally probabilistic and entirely unpredictable. And this sharply contradicts the idea of a rigid block universe where everything is predetermined. So how can we reconcile relativity and quantum mechanics? This is the greatest, still unresolved challenge of all modern theoretical physics. Do you know why? Because we still don't have a complete theory of quantum gravity, one powerful enough to help us draw definitive conclusions. In fact, most current approaches to quantum gravity, from string theory to loop quantum gravity, seem to strongly support the picture of a block universe. However, is this the final answer? Certainly not. And this is the most important thing I want you all to engrave in your minds. This big question remains an unsolved mystery. So, does physics really prove that death doesn't exist? Not exactly. What physics has done is far more subtle and fascinating than that. It has revealed that our deepest intuitions about time, the notion that there is a universal present, that the past simply vanishes, or that death is complete annihilation, All of these might not be as we've always thought. Have you ever wondered if our initial intuitions are truly accurate, or at least partially incorrect? So what if we delve deeper into this mysterious phenomenon of time dilation? Why is this so important? Because it's not just abstract theory, but directly touches upon matters of life and death and the limits of human lifespan. Believe me, this is not a hypothesis or speculation, but a scientifically proven fact. Can you imagine what would happen if you traveled at a significant speed, close to the speed of light? You would experience significantly slower aging compared to those who remained on Earth. Make no mistake, this is not an illusion or subjective feeling, but an undeniable physical and biological reality. Can you imagine? Let's explore a classic thought experiment. A 15-year-old girl preparing for a space journey. The spaceship will travel at an astonishing speed, 98.5% the speed of light. From the girl's perspective, this journey only lasts a mere 5 years. She returns, still in her 20s, but what happened on Earth? An astonishing 50 years have passed. Her classmates are now 65 years old. Sadly, most of her generation are no longer alive. The world around her is completely transformed. This means that she has truly traveled through time, just as we travel through space. However, this marvel is neither magic nor a fairy tale. Don't think this is just a theoretical oddity. In fact, this is a direct and entirely measurable consequence stemming from the principle that the speed of light is constant in all reference frames. To maintain the consistency of this fundamental law, the universe has no choice but to compromise with the very concept of time. So then, what does all of this mean for our individual existence and death? So imagine for a moment, is the duration of a life truly an absolute quantity? 100 years spent on Earth. That seems simple, doesn't it? Yet, that same century can correspond to a completely different duration if you live it at high speed or within an intense gravitational field. And here's a disruptive idea. Death doesn't occur at an absolute, universally fixed moment. No, it manifests at a very specific point in your journey, on what scientists call each being's world line. But that's not all. How about exploring gravity? Because general relativity, that revolutionary theory Einstein published 10 years after his special relativity, adds an extra dimension to this enigma. And here, general relativity surprises us. It asserts that gravity isn't a simple force, as Newton had initially conceptualized it. So what is it? It's a curvature, a distortion of the very fabric of space-time. Who are the agents of this transformation? Objects with colossal mass. Planets, stars, and even the elusive black holes. Around these cosmic giants, the fabric of space-time bends, distorts. And the most fascinating part? This curvature doesn't just affect space, it also has a direct impact on time. So what's the consequence? The closer you are to a massive object, the slower time passes, at least from your perspective. To give you an idea, imagine for a moment, if you could live on the surface of a neutron star, a situation, let's admit, that's unimaginable, to say the least. Time would pass for you at a much slower rate than it does here on our planet. And if we push the experiment even further, what happens near a black hole? More precisely, as you approach its event horizon. Time slows down so drastically that it almost seems to stop, at least if you observe the scene from a distant location. Are you ready for an incredibly fascinating thought experiment? Imagine this. 3 brothers, triplets, all the same age. For 60 years, one would choose to remain on Earth. What about the second? He will fly into vast space, completely free from all gravitational forces. As for the third, he will approach a mysterious black hole. So what strange thing will happen to the brother who approached that black hole? Did you know time will pass significantly slower for him compared to the other 2 brothers? If observed from the outside, the other 2 brothers would be able to. Notice the third brother aging at an extremely slow rate. They would feel as if he were almost frozen in time. The death of the third brother, when viewed from the outside, would appear to be significantly delayed. But what would happen to the third person himself? His biological clock would still function normally. He would not perceive any slowing down of time's flow. And this is an extremely important point that I need to clarify for you, because this is the source of many common misconceptions. Have you ever wondered if you could feel time dilation? The answer is never, because it is directly affecting oneself. Have you ever wondered if time truly passes at the same rate for all of us? That is, every second you experience is a complete second. However, the theory of relativity reveals a surprising truth. Your moments are not at all the same as the moments of others, especially when they are moving relative to you. So where does this difference actually lie? It's formed between the two of you. And this is a difference with profound philosophical implications. Imagine this. If you were to travel at 99% the speed of light, would anything be different? Your heart would still beat normally, your thoughts would still flow as usual, and you would still age naturally. However, the amazing thing is that compared to someone standing still, you would age significantly slower. This means you experience more cosmic time with the same number of heartbeats. So, let's return to a big question, an issue that makes many people ponder. Do you remember I once mentioned that death might just be a misunderstanding? But in what sense? This is how I explain things. Death perhaps is not a complete disappearance as we often think. Instead, it might just be a boundary in space-time, a dividing line that doesn't erase anything at all. It simply delineates a specific region. Everything that happened before that boundary, every thought, experience, and consciousness has already occupied specific coordinates in space-time. And the way the universe operates, these coordinates do not disappear. Therefore, death would be a conceptual misunderstanding, a mistake when we believe that what is no longer happening in the present also no longer exists. However, if time is also a dimension like space, then this argument is no longer entirely valid. For example, the post office on the next street isn't right here with me at this moment, but would anyone dare claim that it doesn't exist at all? So, does it exist in another space? And if time is similar, does something that existed yesterday still exist at a different moment? Not right now, not here, but at a different point, a specific time coordinate. Now, allow me to be frank with you once again. And this is a truth that I particularly love in the field of physics. However, this picture still contains limitations, things that we still cannot fully explain. The first point is, even if the block universe hypothesis is correct, does that guarantee your continued existence after death? You still exist at those past coordinates, yes, but only as a frozen physical entity. Consciousness, subjective perception, personal experience, all these concepts, we still cannot define them at the most fundamental physical level. Whether consciousness can continue to exist meaningfully in the block universe remains an open question. Secondly, the laws of thermodynamics provide extremely important information in this context. Every physical system tends towards a state of disorder. That is the essence of the second law of thermodynamics. This very law explains why a broken egg cannot spontaneously heal, or a shattered cup cannot restore itself. Our bodies, if left to nature, will gradually become disordered as entropy continuously increases. This is the profound physical reason why we age and ultimately die. And even the theory of relativity cannot reverse this harsh law. The third point, and perhaps the most profound. Do we truly understand the nature of time? I particularly emphasize this because it is a self-evident truth. We possess excellent theories about how time operates, how it expands, how it interacts with space, and how gravity bends it. Yet why does time flow in only one direction and not the other? Have you ever wondered why we have the concepts of past and future instead of an undifferentiated flow of time? And what allows us to clearly perceive this present moment? Surprisingly, these profound questions still lack truly satisfactory answers. Even a great mind like Einstein once had to admit this mystery. And Erwin Schrödinger, another genius, agreed with that assessment. So what did the greatest physicists of the 20th century say when confronted with the mystery of time? They frankly admitted, we truly cannot understand what its nature is. In thermodynamics, we see a distinct arrow of time. Entropy always increases, leading to an increase in disorder. It is this law that has shaped and given time an irreversible direction. However, what happens when we look at the fundamental equations of physics, such as quantum mechanics or relativity? Most of them exhibit time symmetry. This means they can operate effectively in both directions of time. And this is a profoundly mysterious and deep asymmetry that science is trying to unravel. But did you know that quantum mechanics poses even more astonishing questions? According to quantum mechanics, an event that has not yet occurred does not exist with a definite reality. A particle might not be in this position, nor in that one. Instead, it exists in a superposition of multiple possibilities. Only when we perform a measurement is it forced to choose a specific value. So does this imply that our future is not predetermined? Does this contradict the concept of a block universe? Or perhaps not. Is it possible that our understanding of quantum measurement is still flawed, not yet truly complete?
Truly, we still don't have the answer.
But there's one thing we know for sure, and that is 20th century physics overturned the simple, somewhat naive notion of time, a relentless flow from the past into the future, sweeping away all events and plunging them into oblivion. And astonishingly, it replaced that notion with something infinitely more complex.
Strangely, unbelievable.
Something that, to this day, remains beyond humanity's complete comprehension. Now, allow me to share something very personal with you. So what truly captivated me so much in this whole story? It's not the prospect of some immortality that people always dream of. I have no intention of offering you false comfort. What truly fascinates me is the undeniable truth that reality always holds wonders far beyond our imagination. As a young man, I faced the pain of losing my first wife, Arlene, to the terrible disease of tuberculosis. She was only 25 years old at the time. I did not leave her side until her very last moment. Please don't misunderstand. I'm not telling this to elicit sympathy. Rather, it's because such harsh experiences help us realize a profound truth. That seemingly abstract questions about time and eternity are in fact incredibly close and present. What truly touched our hearts, the losses we've endured, and what lingers after everything. Does physics bring me solace? Actually, not entirely. However, it sparked my curiosity in a completely new way. She once whispered to me, "You still don't truly understand the nature of time, and perhaps when you truly grasp it, the pain of losing a loved one will take on a completely different meaning." It wasn't a promise nor an absolute guarantee. Instead, it was a compelling invitation, encouraging us to continuously explore and discover. And this is what I love about physics. It doesn't exist to soothe or reassure your soul. On the contrary, it exists to reveal to you that even your deepest beliefs, including notions about the nature of time, the meaning of death, or existence, all deserve to be questioned and re-examined. So what happens when we seriously ask those questions, using mathematics and experiments as our guiding light? We will discover a completely different universe. A universe far beyond anything we've ever believed before. This world is not a collection of entities born and fading away in the endless flow of time. Instead, could the universe be a grand four-dimensional structure, where eternity is absolute, and every event, big or small, is permanently etched into the fabric of space-time? In that case, death would no longer be complete annihilation, but merely a boundary, an endpoint where a specific world line concludes its journey. But is that truly correct? Or perhaps things are not that way at all. Will quantum mechanics force us to reevaluate all these perspectives? And will future quantum gravity theory completely change how we conceive of time? A radical change, similar to how Einstein revolutionized what Newton had established. Isn't this fascinating? We're right in the middle of a captivating story. Do we have all the answers yet? Certainly not. But that's a good thing. Think about it. A universe where we've understood every single corner, would there be anything interesting left? It would surely be very boring. So the next time you suddenly think about death, your own death, or that of a loved one, what will you do? Instead of rushing to conclusions, I just hope you take a moment to be curious, to ask questions. Ask yourself, do I truly understand the nature of time? And do I truly know what it means to no longer exist in a universe where the theory of relativity still holds true? What if death isn't a lie, but just a misunderstanding? It's not a naive illusion to be dismissed, but a profound misunderstanding, an incomplete idea we built based on initial intuitions. All of it was formed without anticipating the arrival of Einstein and his discoveries. And what we call misunderstandings truly are misunderstandings. That is the mission of physics, to correct each misunderstanding with incredible patience, with an unceasing spirit of curiosity, and the honesty to dare to say, I still don't know. When there are still things we don't know, when there are still things I don't know, that's truly wonderful.